All right, here's a video for notes 1-1, number summaries. So first we're going to talk about measures of center, and the two measures of center we're going to talk about are mean and median. So mean is usually denoted by this symbol X with a bar over the top, and we say it as X bar. The mean is the average. So to calculate, we add all our observations and divide by the total number of observations. So we do have to be careful with the mean because it is sensitive to outliers, meaning if you have an outlier on the upper end, it's going to pull the average up, and vice versa with on the lower end. The other measure of center is the median, which is going to be the middle value. So to calculate the median, you have to arrange your observations from smallest to largest, and you're just going to find the middle number. If the number of observations is even, you're not going to have a middle number. So instead what you do is you average the two center observations. So say we have four numbers, maybe a 2, a 7, a 9, and an 11, and we're trying to find the median. Well, the middle would fall right here. Since there's no middle number, we would actually take these numbers and average them. We would do 7 plus 9 divided by 2, which would give me 8. The median is a nice measure of center because it is resistant to outliers. So here's an example of how to find the median from a frequency distribution. So remember, the key thing here that we have to remember is that the median is the middle number. So here it says the following chart shows the number of students who got a particular score on a 10-point quiz. Find the median score. So for instance, the scores ranged between 3 and 10. One person got a 3, 2 people got a 4, 7 people got a 5, et cetera, et cetera. So if we were to list out this data, it would look like this. It would be 3, 4, 4, 5, 5, 5, 5, 5, 5, 5, etc. 1, 2, 3, 4, 5, 6, 7, right? And we can keep going on. However, we're not going to list out all of those numbers because that would take forever. So the whole point of putting it in a frequency distribution, so you can kind of see, okay, well, most people seem to score between a 6 and a 7. But if we want to know what the median is, we have to figure out what the middle number is. So in order to do that, we're going to add up all of these numbers, and that's going to give us the total number of observations. So in that case, that's going to be n. All right, so I have my calculator pulled up. So I'm going to do 1 plus 2 plus 7 plus 15 plus 25 plus 9 plus 15 plus 8. So that means there were 82 total observations. And if the median is the middle number, we need to find the middle of 82. So now I'm going to do 82 divided by 2, which is 41. That means if we were to list out all of our data, right, 41 observations would be here, 41 observations would be here. So that means the middle is going to be between the 41st and the 42nd observation. Okay, between the 41st and the 42nd observation. So to figure out where that is, we need to figure out kind of like the cumulative here. So 1 plus 2 is 3, right? So that means 3 observations are from here and below. 3 plus 7 is 10. So 10 is from here and below. 10 plus 15 is 35. That's here and below. Let's see, 35 plus 25 is 60. So that means 60 is here and below. So that would mean that our 41st observation is somewhere going to be between the 35 and the 60. That means our median score is going to be 7. So we're basically trying to figure out where on the scores is our median score. So again, we have 82 observations. So half of 82 is 41. So that means our median is between the 41st and the 42nd because we're splitting our data in half. And in that case, we need to figure out where this is. Well, we know that 35 scored a 6 or below, and 60 scored a 7 and below. That means our median would have to fall in here, would get a score of 7, which means our median score is 7. All right, so now to find the median from a dot plot, we basically need to count our observations. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27. So that's n, our sample size. And now we're going to divide that by 2 to figure out where our median is. So 27 divided by 2, that's 13.5. Okay, so again, if we have our data, 13.5 would be the middle. That means our median is between the 13th, or we're going to have, that means our middle score, is going to be the 14th point. So we're going to round this up to 14. Okay, so figure out what the median is. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So there's our median, and we can also double check, count the number below, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. There's 13 below, and then count how much above, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 13. So that's how you know that this point is the middle. So the median number of siblings is going to be 3 siblings. All right, lastly, from a stem plot. So this is a stem plot. The way that you read a stem plot is the first number is basically like, well, in this case, the first number is the tens place. The second number is the ones place. So we see that a 1 with a line 0, that stands for the number 10. So for instance, a 3 with a line 3 is going to be the number 33. This would be 34. 34. So it's really similar to a dot plot, but instead of dots, we put actual numbers. So just like before, we're going to count the total number of data, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. And then we're going to divide by 2, which is 10. That means our middle point is going to be between 10 and 11. Okay, so when it's a whole number, you know that your middle point is going to be between two numbers. When you get like a decimal, like 13.5, that would mean the 14th point would be the median. All right, so I'm going to count 10 numbers, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So these are going to be the middle two numbers, and you can always double check by counting below. So 1, 2, 3, 4, 5, 6, 7, 8, 9 below, and then 1, 2, 3, 4, 5, 6, 7, 8, 9 above. So we know that 35 and 37 are the middle two numbers, but remember when you have two middle numbers, you're going to find the average. So 35 plus 37 divided by 2, well, that's just going to be 36. So the median of this data set is going to be 36. All right, so now that we know mean and median, which one do we use? So if we have symmetric data with no outliers, we're going to use the mean as our measure of center. If our data is skewed in any direction, we're going to go ahead and use the median. Okay. And you saw this graph last week, but the way that you can kind of remember where is the mean in relation to the median is the mean will always get pulled towards the tail. And remember, that's because the mean is sensitive to outliers. So for instance, when we have outliers on the upper end in a skewed right distribution, the mean gets pulled towards those values. If we have a skewed left distribution, that means we have outliers on the left-hand side. The mean gets pulled in that direction. When we have a symmetric distribution, our mean and median are roughly the same. All right, so just some little multiple choice practice. So this is a skewed right distribution because the tail is on the right-hand side. That means the mean is going to get pulled towards the right, and the median is going to be closer to the hump. So in this case, the median is less than the mean, or we can say the mean is greater than the median. All right, which of the following is likely to have a mean that is larger than the median? So mean that is larger than the mean is pulled towards the right. This, again, is going to be in a skewed right distribution. So we need to see which one of these would be a skewed right distribution. Well, this should be a skewed right distribution. When we have a difficult exam, most students score poorly, so on the lower end, but few do very well. So in this case, the mean would have a larger value than the median. So in terms of measures of spread, we have range, standard deviation, and quartiles. Measures of spread tell us how much variability we have. So we've already heard about the range. The range, we do the maximum minus the minimum. Sometimes this is a useful value. It gives us our upper and lower thresholds, and then it might detect errors in data entry. However, sometimes the range gives us an inflated view of how spread our data is. So here's an example. So say we have a stem plot and say that the stem plot represents ages of patients. Well, if I'm calculating the range, I see that the largest value is 122 and the smallest value is 4. Well, if we're calculating the range right away, we know that something might be wrong. Because if this is age of patients, I doubt there's anyone who's really 122 years old, which means that this might be some type of data entry. All right, so standard deviation, we're just going to talk about the basics. It basically measures the average deviation from the mean. So it's basically quantifying how far away your points are from the mean. So if this dotted line represents the mean, the standard deviation is quantifying how far apart the points are from the mean. So as we can see, the distribution on top has a smaller standard deviation because the points are less far from the mean. On the bottom, we have a larger standard deviation because the points are much further from the mean. Just like the mean, the standard deviation is sensitive to outliers, meaning if we have a point, way off here, that's going to greatly affect our standard deviation. So because it's also sensitive to outliers, we should only use a standard deviation when we are using the mean as our measure of center, right? So we know that when we have a symmetric distribution, we use the mean as our measure of center, and we use the standard deviation as our measure of spread. So looking at this data, which one has a larger standard deviation? You have to think which points differ the most. Well, in this case, these zeros and tens are gonna differ the most. B is gonna have the smallest standard deviation because all of these points are the same. All right, so 5-number summaries. This is a summary of both center and spread. Well, we know that median is a measure of center. Okay, and we know that the minimum and the maximum are both measures of spread. Okay, but Q1 and Q3 are kind of new. So those are called quartiles. So the first quartile is the 25th percentile, and the third quartile is the 75th percentile. So the way that you can think about it is if we took all of our data and we would just go 25% into the data, that would represent where Q1 is. If we would go another 25%, that would be where the median is, and another 25%, that would be where Q3 is. Another 25% would take you to the maximum. So the median you can think of as kind of like the 50th percentile. And basically the way you find Q1, that's basically the median of the minimum and the median, the middle of the minimum and the median. Q3 is the middle of the median and the maximum. Okay, so 25%, 25th percentile. This is the 50th percentile, and this is the 75th percentile. So another measure of center is the interquartile range. So to calculate the interquartile range, we do Q3 minus Q1. So whatever Q3 is, so it's kind of like a measure like ranges, but instead of subtracting the max and the min, we're only looking at the middle 50% of the data. Half the observations fall here. So this is the IQR, and 50% of the data is inside of the IQR. The IQR is kind of nice because it is a more resistant measure of spread, meaning any outliers on either end are not going to have any effect on your IQR. So we use the IQR when reporting the median as the measure of center. So kind of to summarize, when we have a skewed distribution, right, we use the median as the measure of center, and then we use the IQR as the measure of spread. All right, so to find a 5-number summary, if you have a small set of data, it's pretty easy to find by hand. So I'm just going to walk through that, and then I'm going to walk through how you can do it electronically. All right, so looking at this bottom one here, we know that 19 has to be the minimum and 32 has to be the maximum. And note that the data is already in order, so we don't have to worry about that. And then to find the middle, like we did before, the median, we're going to count the number of observations. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So n equals 13. And then we're going to divide that by 2. 13 divided by 2. Oops. 6.5. So that means the 7th point is going to be my middle point. So 1, 2, 3, 4, 5, 6, 7. This right here is my median. And you can always double check to make sure, okay, there's 6 below and 6 above, so I know that's the middle. And now to find Q1, we're going to take the lower half and we are going to find the middle there. So we're not going to include the median. We're just going to look here. So 1, 2, 3, 4, 5, 6. Q3 is going to be right here. So that's going to be a 23. And then the middle here is going to be between, oops, sorry, this should be Q1. Q1, and then Q3 is going to be between 29 and 30, so that's going to be 29.5. So my 5-number summary is going to be 19, 23, 26, 29.5, and 32. So let me show you how to do this using technology. All right, so we're going to use GeoGebra as kind of our online calculator. And you can access GeoGebra on Canvas. If you click on GeoGebra, it should open it up here just as kind of a web browser. Okay, then what you're going to do is you're going to open a spreadsheet. So to do that, you're going to click this, and then you're going to click the 3 dots, and you're going to click on spreadsheet. And then what you can do is you can actually close these out here. So you can click close here, the 3 dots, and close. And then what we're going to do is we're just going to enter in our data here. So I'm going to enter in this data. So 45, 68, 74. 75, 76, 82. 91, 93, 98. And when you're putting your data in GeoGebra, you actually don't have to put it in order. So even though these are already listed in order, you don't actually have to worry about that when putting it in GeoGebra. So then in order to calculate your 5-number summary, what you're going to do is you're going to highlight your data here. Okay, and then you are going to click on this and you're going to click one variable analysis. And then once you have that, you're going to click on, that's going to give you a graph. Then what you're going to do is you're going to click on this symbol right here, which should say show statistics. And then it calculates everything here. So it calculates your 5-number summary, 45, 71, 76, 92, 98, as well as your mean and your standard deviation.